In this video, I'm going to go through a step-by-step method on how to find eigenvalues of a 2x2 matrix as well as eigenvectors of that 2x2 matrix. So step number one is you find A minus lambda I. I, by the way, stands for the identity matrix, which in a 2x2 matrix is of this format here. And straight away from that, we can form an expression for lambda I. So lambda I is what you get when you multiply each individual component of the identity matrix by lambda. So 1 times lambda is lambda. These two would, of course, just be 0 because anything times 0 is 0. And then this here would be lambda as well. If we're doing A take away lambda I, let's form that expression first before we find its determinant and make it equal to 0. So A is our matrix that's given in the question, by the way. So that's, in this case, minus 6, 3, 4, 5. So I'm just going to write that out very quickly. Minus 6, 3, 4, and 5. And we're taking away from that this matrix that we formed for lambda I, which is lambda, 0, 0, lambda. Now, when we take away, it honestly looks more difficult than it is, but all you're doing is this component take away this component. So minus 6 take away lambda. Here you're doing 3 take away 0 to get this answer here, which is 3. 4 take away 0 is 4. And then 5 take away lambda is 5 minus lambda. What we now need to do is find the determinant of this matrix and make it equal to 0. So the determinant of any 2x2 matrix in the form A, B, C, D is given by AD take away BC. So that's the top left times the bottom right, take away the top right times the bottom left. So let's apply that here. Sorry if my handwriting's bad, by the way. I just got a new stylus. I'm getting used to it. But here, now we're going to find the determinant. So which is AD in this case, minus 6 minus lambda, all multiplied by 5 minus lambda, take away 3 times 4, which is 12. And we're going to make that equal to 0. Now let's expand out. So minus 6 times 5 is minus 30. Minus 6 times minus lambda, you have to be careful here. It's a positive 6 lambda. Minus lambda times 5 is minus 5 lambda, and minus lambda times minus lambda is plus lambda squared. All take away 12 is equal to 0 in this case. So let's write that out. Take away 12 equals 0. We can now collect like terms, so we have just one squared term of lambda. 6 lambda take away 5 lambda is plus 1 lambda. And lastly, minus 12 take away 30 is minus 42. And then once you make that equal to 0, I'm sure you spotted already, but the factors are positive 6 and minus 7. So if lambda plus 6 and lambda minus 7 are both equal to 0, then the values of lambda that would make the left-hand side equal 0, well, you can just make each bracket equal 0. And lambda equals minus 6 makes the first bracket equal 0, and lambda equals positive 7 makes the other bracket equal 0. I'm going to call these lambda 1 and lambda 2, and these are our two eigenvalues. So to get the eigenvalue, you take the matrix in the question, you subtract from it lambda times the identity matrix, just like we've done here, and then you find the determinant of that matrix and make it equal to 0. So we've got the I'm tripping over my words. We've got the eigenvalues. Let's now find the eigenvectors in a different color. So to find the eigenvectors, I wrote here step number 2, and we're going to have to use that here actually. So our matrix A, oh, one thing I just realized, this shouldn't say A, it should say A minus lambda I. Lots of everything here equals 0, 0. So when we put it into this equation, A minus lambda I, by the way, is just this equation here, isn't it, that we formed beforehand. So what I'm going to do, a bit of a cheat code, but I'm just going to copy and paste everything here, just so we can carry on to the next question and I don't have to write it all out again. So that's A minus lambda I already, multiplied by xy is what we're going to make equal to 0, 0. But we need to do it for each individual eigenvalue to find the individual eigenvectors. So let's start with lambda 1 that I introduced. Lambda 1 equals minus 6 here. When you put minus 6 as lambda, what you get is, well, minus 6 take away minus 6 is minus 6 plus 6, which is 0. 3 take away, oh wait, 3 has no lambda attached to it, so it's not affected by this value. 4 also has no lambda attached to it, but this value does have lambda attached to it. 5 take away minus lambda is 5 plus 6 here, which is 11. And then you set that multiplied by xy to be equal to the 0 vector, 0, 0. Now, in order to solve this, 0x plus 3y would equal 0, but that doesn't really help us. Instead, we can form an expression using this other part of the vector. So 4 times x is 4x, and then plus 11 times y is 11y, and all of that is going to be equal to 0. So what that means is, if we think about it, well, I think the easiest way to do this is if we take away 11y from both sides, we get 4x is equal to minus 11y, and then divide both sides by 4, we get that x is equal to minus 11 over 4. That tells you that if x is equal, sorry, minus 11 over 4y. That means that if y is equal to 1, x would be minus 11 over 4. So this acts as the eigenvector for this specific eigenvalue. Let's now find the other eigenvector for the other eigenvalue. So this time we're going to take lambda as 7. When you do that, this expression becomes minus 6 take away 7, which is minus 13. This on the top right becomes 3. On the bottom left it becomes 4 because it's unaffected by lambda. But 5 take away lambda now would be 5 take away 7, which is minus 2. All multiplied by xy would be equal to the 0 vector, 0, 0. Okay. Here I'm going to pick out the bottom equation. I think it's going to be easier to solve. 4 times x is 4x, and then minus 2 times y is minus 2y, and that's all equal to 0. Add 2y to both sides, so you get 4x equals 2y, and then you can divide both sides by 2 to get that 2x is equal to y. That means that no matter what your value of x is going to be, so for example if it's 1, y is always going to be 2 times the amount. And so this is the eigenvector for the specific eigenvalue when lambda is 7. That's the one that we took beforehand. And that's the answer to your question. We found all the eigenvalues and eigenvectors. Let me just zoom out one more time. And we see that when the eigenvalue is this value here, minus 6, the eigenvector is this difficult looking vector. But when it's 7, then the eigenvector is 1, 2. That's a bit easier to deal with, and that's everything that you have to do for this question. Hopefully it makes sense, and these two steps that you have to remember, this one and this one, you are able to remember them. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.